Welcome to Spring LIB.
In this problem, we have basically an equation that kind of says the acceleration of someone's head in a whiplash, or when in a whiplash situation. So we found that the angular acceleration is related to the displacement, angular displacement, by this relationship, and we want to find the angular velocity of the head when theta equals 30 degrees. Okay, so again, we know that the angular acceleration is the angular time derivative of the angular velocity, or we can write it as the angular velocity times the derivative of the angular velocity with respect to the angular displacement. So we can basically, if we separate variables here and then integrate, we get an integral from 0 to theta. We're assuming that it starts at 0 and goes to theta of alpha d theta bar, and then we assume that it starts it from rest, omega equals 0 to omega bar d omega bar. Now, we can use this expression here, plug that into here. Integrating this, we just get 1/2 omega squared, and then we can integrate this and evaluate it from 0 to theta, and we get 700 sine of theta plus 70 times the quantity 1 minus cosine of theta. That gives us an expression we can then solve for omega, and then plug in theta equals 30 degrees, and we wind up with the angular velocity at this angle here is 26.8 radians per second. I don't know. Again, I'm assuming that that's probably not good, since this was in a whiplash experiment that someone's head is being accelerated rapidly, usually backwards. And again, this happens a lot in rear end collisions.